Hello everyone, thank you for joining our webinar Hopsteiner Forum once again. Today we have the presentation about unleashing the potential, a comparison of hop pellets and extracts. My name is Sandro and I'm working for technical support, and I would like to give a very short introduction. Our webinar is scheduled for 1 hour, starting with a presentation of 40 minutes roughly, followed by a Q&A session. During the webinar, your camera and your microphone remain switched off, but you can address your questions and your comments through the Q&A button. The presenter of today is Stephan Raeker. Stephan Raeker is our sales director for Asia at Hopsteiner, Germany. He is responsible for our business in Asia due to his strong connection to this region. He also lived a couple of years in Singapore and Tokyo. Even though he's called sales director, Stephan has a strong technical background in beverages and flavors. After 20 years in the global flavor industry, he joined Hopsteiner 3 years ago. Since joining our company, he closely worked with brewers in Asia to create successful hop solutions for their beers. Stephan, we are curious about your presentation today, and also how to improve the hopping with regard to the bitterness and aroma, resulting in less hopping costs but remaining bitter beer quality. Thank you. The stage is yours.
Sandra. Thanks so much.
See you later.
Well, hello everyone out there. This one is going to be a little push open of the door to the world of extracts. I know that many of you might not be experts in that topic, but always there are some people who know all the ins and outs of it already. I promise that most of you will get at least 1 or 2 things out of this. So let's take it away. Who are we at Hopsteiner? We are basically one of the major hop processors and traders in the world. We have everywhere locations around the hop belt, which is usually around the 35th to 55th latitude, and that's where the hops is, and that's where we are. Our business is about working with the growers. We are a grower ourselves in the US, for example, as well. And a big part of what we're doing is processing the raw hops into different kind of hop products. A big part of how to get to the hops is also our breeding program, where we create our own future-proof varieties of new hops, which are more resistant to climate change and give you a better yield in the brew house. And that's what we're going to focus on for today. A lot of what we do is coming from the passion for beer. We have many brewmasters and seasoned beer experts in our company. And that is why we want to be the consultant, and we want to be the partner when it comes to solving possibly technical issues when it comes to the brewing process related to hops. Now, hops, there are so many benefits that you get out of hops when you use it for the beer brewing process. It starts with the things that the consumer can perceive, the bitterness, the hop aroma, but it also has many technical benefits that are only for the brewer, to kill the bacteria in the wort, to create a well-rounded bitterness, to have special products for light stable beers, which are filled in clear glass flint bottles, also to manage the foam stability and cling. So there are many benefits of using hop products. And nowadays, the evolution of how to use hops has really changed over the last couple of years. Nowadays, compared to the history, you're not only using hops in the brew house at the beginning of the boil. That was the traditional way of hopping, of course, giving early addition for bittering and a later addition for aroma purposes. But what we see today is the evolution of products related from hops, which have become a lot liquid in the past several years. Liquid as a form of hop products makes them wider applicable, and you see when you're adding hops later in the beer stages, in the brewing stages, you basically have a lot of options that you won't have with a normal pellet type. So where does it all come from? This is basic for most of you who are dealing with hops and beer. What we're after is what we find in the hop cones. In the left picture, you see the little yellow dots, which are the lupulin glands. And in this lupulin, there's where all the magic is. We have the resins on one hand side, which are mainly about the bitterness and the performance of hops. And we have on the other hand side the aroma part, which is coming from the hop oils. Now you can extract those in terms of extracts that you see on the right hand side. There are different ways how to extract the value out of the hop cone if you're not pelletizing it in the usual way. It has led to a very wide variety of different hop products, and many of them are very specific to only one task in the brewing process. When you look to the left-hand side, you see all the dry products, the pelletized products. Those are basically different stages of concentration from the original hop cones. There's still physical processing of crushing the leaf material, removing it, and concentrating the lupulin content in those dry hop products. When you go to the right side, I don't want to go into all the details in this presentation, but there are many different extract types and many different byproducts of extracts which have brewing value specifically catered for. Most of those start from the CO2-based extracts, which are the common and most standard extract product in the hop world. If you compare those different hop types, the different hop products, you can actually differentiate them from their closeness to the original hop cone. So you have some products which are very close in their composition to the original hop cone, and some others which only have isolated value components out of the hop, neglecting all the rest of it. So the closest in composition to the original hop cones as it grows and is dried in the fields are the pellets. Type 90 is the closest one. The type 45 is a concentrated version, which increases the volume, the level of lupulin in the pellet. You can further refine those kind of pellets into pre-isomerized pellets. We're talking a little bit about this later, or stabilize them to better enable the yield in the brew house. After that, we are entering the world of extracts, and the closest extract to the original composition of the hop cone is the total resin extract, which is done using ethanol as a solvent. CO2 extract, which is the most common one, is a little bit further away from the original hop composition because it's a very selective process. And this one, however, is the starting point for many other extracts which are pre-isomerized or further refined. It's also the starting point for all the downstream products, those products which are used in the cold block of the brewing process. And there you have really a lot of different choices, very specifically catered to specific brewing needs. Now let's look into the pellets first and why there is a reason for coming up with extracts in the first place. It starts with the brewer's dilemma. When should you dose your hops? If you do it early in the boil, you get the maximum yield of bitterness. You transfer the alpha acids, which are part of the hops, into iso-alpha acids, and that is what you want to have because that's giving you both the bitterness and the technical performance for the brewing process. However, if you add your hops very early, you're basically evaporating all the aroma which is in those hops. If you add the hop late, you get a much higher yield of the aromatic parts. The hop oil is not cooked off in this process of brewing. It stays more or less intact. But the dilemma is here, you have to make a choice. You're either losing one part. If you add early, you're losing the aroma. If you add late, you're losing the bitterness. This dilemma, of course, has a solution for most of the brewers. You add a little bit at the beginning to give you the bitterness performance, and you add the rest at the end to give you the aroma impact that you want to have. But still, you're losing one part because nature has put these two parts together. They're both in the hop cone, they're both in the hop pellet that you're using. And that's why splitting those two hop would be a perfect idea to stop wasting one share of it. And that's what we can do in the hop industry to separate those two, which is impossible to do in the brew house. So on the one hand side, you have the bittering part, which gives you the performance for brewing, which is mainly focused on the alpha acids and the isoalpha acids that come out of it. The other side is the aroma and the flavor impact, which mainly comes out of the hop oils. So in order to give you this bitterness part, there are different kind of special extracts. CO2 extracts and all the other conventional extracts are more or less used only for this purpose, because they are mainly coming out of bitter varieties. If you're using isomerized extracts or pre-isomerized pellets, this is also a way to improve on the performance of a traditional type 90 pellet. On the aroma side, you have different kinds of aroma extracts, like our salvo range of extracts, and you have those hop oils, which are only the hop oil or isolates thereof. In the following, we're going to explore those two different routes, and I'm going to show some of the backgrounds, some of the do's and don'ts, what it can do and what it cannot do. So let's start with bittering. I think it's interesting to first look into the composition of the different hop products, starting from the hop cone to the traditional pellets type 90, type 45, and the conventional, not pre-isomerized extracts. We can neglect water because that's in there as a natural part and it needs to have some humidity, otherwise everything would crumble. The focus for our part here is the bittering substances. This is mainly alpha acid, but it's also beta acids and some other non-specific hard and soft resins and the different substances linked to it. You see from this comparison that the cone hops and the P90 are almost the same. P90 is a little bit more strongly concentrated. The P45, type 45 pellet, has a higher concentration level of bitter substances. When you look to the extracts, they're almost completely bittering substances. That's why we call them total resin in the case of the ethanolic extract. And even the CO2 extract is mainly consisting of the bittering components. You see that when we bring in the tannins, which are coming from the leaf material, you do have those in the pellets, not so much in the extract anymore. And the hop oils, you also see a strong concentration in the extracts. The simple fact is that resins and hop oils both come from the lupulin and they stick together and they are close, so they are both enriched when you enrich the lupulin total content. Now, the others we can neglect in this case because that's not really giving you brewing value. But extract is not extract. There are different types, there are different solvent systems. And in the picture here, you can see three different types of extracts in real life. The two left ones, the total resin extract and the CO2 extract, they were dissolved in water. And dissolved, I need to put into brackets because you see it's not as nicely dissolved in the case of the CO2 extract. The reason for that is simply its polarity. It's very selective, and therefore the same that happens here in this picture of water is happening in the case of your beer. That's why you need to boil the CO2 extract to make it solve in the wort and make its way into the beer. The total resin extract is also not completely solvable in water, but it has a much higher close proximity to it. The hop oil on the right-hand side is also an extract. Many people forget that. These hop oils are primarily generated out of fresh hop cones, which are steam distilled. And that's a very, very traditional extraction process, which has been used around the world for botanicals since the time of the French Revolution, I think. So those different kind of solvents have different properties, and that leads to different outcomes in terms of the products that come out of it. Let's look again in this picture what is in the hop cone. You have the soft resins and the hard resins. Of course, there's also the hop oil in there, but let's focus on the bittering components for now. If you use CO2 as a solvent, it's mainly focusing on the soft resins. A very good reception of the alpha acids, the beta acids, and a part of the non-specific soft resins. But CO2 is specific. It's very selective in its extraction purposes. Ethanol, competition, you could say, in terms of the solvents for extracting hops, is much more broad. It gets basically everything out of the hop cone which is of value for the brewing process, including the hard resins and much more of this non-specific soft resins as well. And that has an effect on the extracts that you can generate out of it. The CO2 extracts, since it's selective, usually comes with a little bit more pronounced, sharper bitterness profile. Not as round and balanced as you would expect it from a hop pellet, which is similar in the ethanol-based extract, which we call the total resin extract. Ethanol, since it's such a perfect solvent system for any botanical, not only hops, is basically getting everything of value for the brewing. And that's why the bitterness profile coming out of it is usually a little bit more balanced. Now, whenever we recommend, let's not only go for the CO2 extract, but broaden the spectrum to total resin extract, we often get a question of why should we do that? Hopsteiner is one of the few companies in the world that still offers those ethanol-based extracts. So we would not limit ourselves in supply. Well, there are two reasons for considering it anyway. The first is there's a very simple way to reconstitute a total resin extract, even if you're using CO2 extract otherwise. The difference is in the hard resins, in the non-specific soft resins. If you add those with a little bit of pellet extra dosage, you are easily matching the profile of a total resin extract. In the end, it does not really make a big difference anyway, because you're using both of these extracts at the beginning of the boil. All the differences will be basically boiled and cooked. Now, one big advantage of the ethanol-based extracts is that it's easier to process, because the CO2, as it's so selective, is not able to penetrate a raw hop cone. You need to remove the plant material, you need to pre-pelletize it, and then you can feed it into the CO2 extractor. Ethanol is such a broad-based extract solvent, it doesn't care about it. So we can use the raw hops after it's dried, and it's fully extracted without this extra step of processing, without the cost, which are obviously linked to such an extra processing step. And that's why we always say, consider it, it might be an actually good option to complement. But there's not only the conventional extracts, there are many others that I already showed you on the big overview page. What makes them interesting is if you compare their efficiency, their yield in the brew house. Now, the traditional pellets, they have the problem mainly based on the yield. So if you consider a typical type 90 pellet, the best brew house in the world can maybe slightly exceed 35% of yield, which means the alpha acids which are in the hop pellets are transferred into iso-alpha acids during the brewing. Now, for everyone with a commercial background, that must be very painful if you consider your hop bill and the money that you pay for it. Because if you have 1 kilogram of alpha acid that you pay for in the form of pellets or whatever, it means that from this 1 kilogram of alpha acid, only 350 gram will make their way into the beer. 650 gram, 65% will be wasted for the bin. And that's a lot of money wasted. And that's where the big difference between those different hop products comes from. Because the higher the yield, the more easier the adoption into the beer of the alpha acid which is there. And you see this clearly with the pre-isomerized products. Even the normal extracts, they're not much better than a normal pellet. They're a little bit better because they're more concentrated and easier accessible, but there are physical limitations that you cannot overdo. There's a natural ceiling as far high you can go. With the iso pellets, when we do basically mimic the isomerization process that's happening in the beer brewing in our factory, then you can achieve levels of easily 55 or 60% of yield, especially when you look to the isomerized cattle extract, the Ike. Ike is a product we are going to talk about a little bit later again. What you also have on the right side are the downstream products, which can be used in the cold block. They don't need to be part of the boiling. So those products are super efficient when it comes to the yield. However, anyone who would think using an iso extract, which is by far the most efficient hopping when it comes to the bitterness, they would be very disappointed about the taste, because the bitterness would be very sharp, pointed, and unpleasant. That's why we usually recommend a maximum of 30% of the bitterness units for the beer should come from the downstream part. The rest should be really from the brew house. And there, the Ike is certainly the most efficient solution that you could look at. There are also other options for light stable beers. If you plan to fill your beer into clear glass flint bottles, you cannot use the natural, normal hop products. You need to reduce the iso alpha acids to make them light stable. Otherwise, you will have a very unpleasant light struck flavor, which no consumer will really appreciate for sure. But bitterness is not the same as bitterness. There are different kinds, and there are different kinds depending on the different compounds which are creating the bitterness. And when you look to the reduced iso alpha acids, or alpha acid as it is untransformed, you see they have an analytical value, of course. You can measure them, but that's only half of the truth, because the measurement does not necessarily represent the sensory perception of the consumer. So in the example of the alpha extract, for example, the alpha acids, it is measured as close to 0.8 on this bitterness IBU level per ppm, but the perceived bitterness is much lower. And in fact, it's not as pleasant as well as iso alpha acids, because it's a little bit broad in terms of the taste perception of this bitterness type. The benchmark is always the traditional iso alpha acid. 1 ppm equals 1 IBU, 1 international bitterness unit. But it's not the only one when it comes to the bitterness impact, because you can have the tetra reduced acid, which is measured lower in terms of the analytics, but perceived more bitter, more sharp, more pungent in some cases. And that's also one of the issues that comes with some of those reduced iso alpha acids. We have the Rho, we have the Hexa, we have the Tetra. Those are not as clean usually as the iso alpha acid. Rho is by far the best of this in terms of the profile of the bitterness. Tetra comes out a little bit pharmaceutical and metallic sometimes, and Hexa might become across hard and lingering in the bitterness. So this is why it's always a fine balance of what kind of hop product to use if you want to have a light stable beer. The big benefit is that the pre-isomerized products are always much more efficient. And you see this in this comparison of traditional extract versus an isomerized extract. Or you could also take this graph as a normal P90 pellet versus a pre-isomerized pellet. The logic and the ratio is more or less the same. So if you pre-isomerize, you have one big benefit. You don't need to add the hops as early to achieve the same performance. Those hops are already pre-isomerized. So the job that's supposed to be done during the boiling with the hops is done by the time you add it. Of course, you cannot just, if you interpret this chart, reduce your boiling time to only 10 minutes. That would not have all the effects that you want to achieve with the boiling in the brew house. You have to manage your mold side, you have to get rid of diacetyl and all these other aspects. But when it only comes to the hop part, 10 minutes would be enough. And that's why many people are using those hop products very late into the boil, because it has another benefit we're going to talk about a little bit later. What should not be neglected, though, is you cannot make a one-to-one copy with those different products. There will always be slight differences. Maybe not to every consumers, but certainly to the experts and to the heavy users. The bitterness profile of pre-isomerized products is a little bit more pointy, sharp, and it comes out quicker and is not as fully rounded and well balanced as it is when you let nature take its course. When you have alpha acid containing extracts or pellets, give them the time during the wort boiling, and they pre-isomerize in the most natural way. This kind of bitterness release and intensity is perceived as being the most rounded, and that's why only pre-isomerized products are not for everyone. And that's something you should keep in mind for everything that we show here. It's always a balance and a decision to take where do you need it for and how far are you willing to go. But let's look into the aroma side for now. We want to show you some of the benefits as well that are not linked to just the bitterness, which is the focus of many brewers when it comes to the traditional beer styles. But the aroma side is certainly the big part when it comes to all the ales and pilsners and beers which are a little bit more strong on the hoppy and aromatic side. If you're brewing these kind of beers, the first issue is coming from the pellets. What you throw in are those nice little small pellets. They don't stay like that. They bloat up, they soak up wort or beer if you're using them in dry hopping. And usually we say the volume is extended 6 times. The weight is even more, up to 12 times the weight compared to what you put in at the beginning. And this means basically 2 things. First of all, everything that's soaked up is your very valuable wort or beer. So you're losing this. And it's easily 20 to 30% loss when you think about heavily hopped beers like IPAs, especially when you're heavy on the dry hopping side. If you do a light lager, of course, those losses will not be so significant. Still, you have this issue of removing the plant material, and every brewmaster will attest to that's not the most favorite part of brewing, getting those hop residues out, because it's part of the hot troop. It's partially removed. You can try it with filters, you can try it with centrifuges. It's never really that easy and straightforward. So it's one of the most unpleasant parts of dealing with the hop cones and hop pellets. But there's an extra benefit of the bitter products, especially the isomerized kettle extract, the EIK, that I want to highlight here. If you're using them late as you can, they have an extra benefit, and that's happening after the first 5 minutes. So if you add those extracts close to the end of the boiling, you're getting a lot of the oil, which is also in the isomerized kettle extract, like it was in the CO2 extract, and get it into the beer. So you can actually give your beer a nice push from the bitter hop side and giving you a sound foundation of hoppiness in terms of aroma and flavor. And that's something that should not be forgotten, because these kind of products, due to the late addition, can have this extra benefit. But let's focus on the pure aromatic products for a moment. One of the products that we are promoting is our range of Salvo. It's a different type of aromatic extract. It mainly consists of the hop oils, plus some of the bitter acids, which give and add to a nice rounded mouthfeel. And those extracts are really focusing on the aroma and flavor. So they don't give you additional bitterness because the beta acids are not really soluble in beer, and there's no alpha acids anymore since we've removed them. We recommend adding those products into the whirlpool because the residual heat will help in the dissolution and will activate the hop oil for the later stages during fermentation. There's no vegetative matter in this. It's only extracts, and this means no loss of beer or wort. easily 15% more beer if you consider a heavily hopped IPA, for example. Another benefit that should not be forgotten, not in the brew house maybe, but certainly when you think about storage, shipping, the volume of those extracts is much lower than with a normal pellet. It's much concentrated, and I will show you some of the overviews of what this could mean in terms of the scale that you are looking at. Salvo is basically focusing on the aroma side, and it's our major product for the late hopping, so whirlpool additions. On the right-hand side, you can see a comparison, just comparing hop pellets and the hop group that you have there versus using hop extracts like Salvo, but also like CO2 extracts or others. You don't have that additional hop group which is soaking up your wort. On our website, we have a special section for all the Salvo products. They give you a dosage recommendation and easy usage guidelines. So if you are using pellets today and you want to replace those with a liquid aroma extract, this will give you a recommendation how to do that and what kind of ratio. But I want to go one step further in the aroma side. Salvo as an aroma extract has non-hop oil parts still with it. What we are focusing on in Germany at the moment for the global promotions is also the hop oil part as it is, so only the hop oil. And for hop oils, there are different types that you can deal with. The most traditional type, and that was the picture that I showed you at the beginning, comparing to the CO2 extract and the ethanol extract, let's call it crude hop oil. That's the hop oil as it comes out of the hop cone by steam distillation. It's 100% of the composition of the original oil. So this is the taste of the variety that you are selecting. That usually sounds very positive to most people. 100% composition of oil, all the taste. It's not necessarily the best product, because these kind of products, yes, they can be variety specific, but since they have 100% of the composition, some people in the beginning wanted to use them very late in the cold block of brewing. So they added them close to the final pumping into the BBT. And then they were very unhappy with the flavor profile of the beer, it turned out. So even if they took something pleasant like a Cascade oil or Hallertau tradition oil, the beer that they did with this kind of oil did not taste like if they did it with the normal pellets. And the simple reason for that is that the oils which are in the hop are changing in the taste and impact throughout the brewing process. They change when heat is involved at the beginning. So let's consider you add them late in the boil, in the kettle, or in the whirlpool. There's some temperature effect that's changing it. Then you go into the fermentation part where the yeast activity is changing the flavor profile further. And you end up in the beer after some storage time. It has a very distinct taste, and that's what you usually want as a brewer and as a consumer. If you use the isolated hop oil for that, which has 100% of the composition, it's 100% of the composition as it was in the raw hop, not gone through all the processing of the brewing process. And therefore, you bring in aroma compounds from the hop oil, which you don't want in the beer, which can be very sharp, harsh. Molecules like myrcene, limonene, they can be very unpleasant in beer. So this led to the generation of the other families of hop oils that we have, type noble, type essential especially. And the difference to our type dry, which is the 100% hop oil, is that those specific varieties of hop oils are top notes only. They're isolates, which take out everything that you want to have in a beer and remove the rest by vacuum distillation, fractional distillation. Myrcene and all those other things, they are evaporating in the brewing process. If you want to add your hop oil late in the process, close to the BBT, then this kind of products are what you should go for, because they don't have the unwanted compounds in it anymore. They only bring in what you want to have in the beer. And that's reflected in the dosing recommendations that we give. Those kind of products like the hop oil noble, type essential, type selected, and also the botanical additions that we have, they are added very late. To be on the safe side, we usually say use them before the last filtration step. We know that some people do it even afterwards. What you need to make sure is that at least there's a pumping step before you add the hop oils, because I guess most BBTs don't have a stirrer inside and you want to have an even distribution of your oils. So the last pumping step will ensure that it's nice and thoroughly mixed, and that makes an even distribution in the beer of the hop oil. Using the type dry, which is the 100% composition of hop oil, is only recommended into whirlpool. You can also maybe use it close to the fermentation or in the fermenter, but it's necessary that this hop oil undergoes some sort of biotransformation and evaporation of the unwanted components that you don't want to have in the beer. So that was the theoretical part, I could say. Now let's talk about money. Talk is cheap. I want to share some real-life examples of how those products perform when you use them in brewing. Of course, this section has to come with a big disclaimer. Talking about cost and money can only be wrong. It will always differ from what you experience out there, because on the one hand side, you're comparing hop pellets, hop extracts with different alpha levels. Maybe I put an example with 16% alpha as a hop pellet in there, and you only get 14% in some crops. You have variations of crop years. You have variations of hop varieties that you're using. You have different costs. X works in our factory is one thing, but if you're exporting the hops to countries which are far away from Germany or the US, where our factories are, you have to pay off for the transport costs, the customs, the duties, everything on top. So whatever I'm showing you can only be wrong. But you can make it right, of course, by filling in your own pricing information and your own details. So what I'm providing here is basically a blueprint for you to make your own comparison and make it yours, so that you can really validate what kind of effect it would have if you're using these kind of products. Now, for the purpose of this, we selected two base recipes. One is a German Pilsner, which comes with a little bit lower IBU level than a German Pilsner would usually be. We fixed it at 20 IBU, and we wanted to have a very strong hoppy note, and that's why we fixed the linalool content, which is the main compound to give you this nice hoppy aroma, at 40 microgram per liter. So what we did was basically have three recipes in parallel. One is 100% based on pellets. So in this case, we have a bitter addition of Hercules, 16% alpha acids, to reach 13.2 of the IBU of 20 that we want to have at the rest. The rest is the aroma dosage with hallertau addition, added late into the wort pool, and it still gives you some of the IBU to reach the final 20. Compare this with the same beer, but instead of the pellets for bitterness, we use international bitter CO2 extract. So we get the same type of bitterness from the CO2 extract as we did it from the pellets, from the Hercules pellets at the beginning, and we stick to the hopping with pellets for the aroma part. And the last one of the three is the ultra downstream version. So it's using EIK, the isomerized kettle extract, for the bittering part, and it's using hop oil type noble, which is giving you this Pilsner lager type kind of hoppiness. It's specifically catered to give you a nice aromatic hoppy note. So when we compare the costs of these, of course, having 40 microgram per liter linalool is a very hoppy beer. So the cost of this recipe using pellets is quite high. And again, as I told you, you can fill in your own values of the landed cost that you have for those hop varieties. In our example, it leads to close to €1.50 per hectoliter. We do the same beer with the extracts. We need, first of all, much less of the CO2 extract compared to the Hercules pellet. Instead of 27.5 gram per hect, we need 7.5 gram. But you see the cost ended up the same, even a little bit higher. And if we compare it to the version which is using Ike and the hop oil noble, again, we have the same cost. So what did I do? Maybe not very clever to select this sample. No, of course. All of the costs are the same. Why bother? Why should you switch from a pellet-based to an extract-based version, which I told you will not be 100% same taste? It will be perceived to experts, certainly, and maybe many consumers will also see a difference if you have an established, well-selling beer in the market and you switch it to extracts only in the right side. So, of course, this is only half the truth. I selected this example for a purpose. The first benefit of having the right side recipe, we talked about a little bit earlier. We have those extra benefit of using Ike because it has hop oil content, which if you add the Ike late into the boil, close to knockout, you get into the beer. So in reality, for this beer recipe, we would never have to add 4 gram of hop oil noble. This beer is much more aromatic than the first two are. I wanted to put it anyway, like this, because this is a clean-cut comparison. If you compare the beer, usually if you want to have a sensory match, we could go with easily 3 gram of hop oil only, and then it would be significantly cheaper already. But again, that's not the whole truth. There's more to it. And the extra part of the story is that there are some hidden costs in using conventional product and especially hop pellets. The first one is the wort and beer loss, and we talked about that. You've seen this picture before. In our case of this recipe, we're adding aroma pellets, and that's the only thing that I put here. 136 gram is not that much. Still, it bloats up, it sucks up wort. You're losing around 800 gram of wort per hectoliter. Still, you could say, okay, that's not too bad. But think about doing an IPA, where you can easily put 1 kilo, 2 kilo of hops, and it's blowing up 6 times, 12 times in weight even. That's a different story. That's a different cost to link to it. So you can easily calculate what kind of loss you have and what kind of money this will mean as an extra loss. But there's a second aspect, and that one is often neglected because it's not part of the brewing process. When you look at brewing, you look at what are the costs of the ingredients that I put in. That's what I compared at this page before. But again, it's not this full story. You can calculate the losses in, that's already an extended calculation model, but hardly anyone has ever taken the shipping and storage cost in. And that's a big, significant amount of money. If you compare the volume that we ship around the world with different hop products, take the index of 100% as a hop bales, P90 is already quite concentrated because we're removing the plant material, we're crushing it. It's still very close in composition, of course, as mentioned, but weight-wise, volume-wise, it's much more concentrated. Now, if you compare that to the CO2 extract, and you could take any other extract like the Ike, has the same kind of volume, then it is further reduced in volume. And if you look into the hop oils and those aromatic extracts, they're only a fraction of the original volume. And when you consider how much you have to pay for shipping in containers, especially if it's cold reefer containers, how much you have to pay for cold storage costs, especially if you're living in a country which is not very cold all year long, then this comes to a significant amount of money. And that's something that should be calculated always. And only that makes the full total cost of ownership calculation complete. But let's look into the second example, and that might be a little bit more straightforward. For this one, we took an American Pale Ale, toned it down on the bitterness, only 30 IBU, but we gave it a real hoppy boost. We took linalool as the key measurement lead compound here, even though this is not about giving you the same kind of hoppy flavor as a Pilsner or a lager. This one's going to be more fruity, but still in terms of measuring the equal weights, we put it as linalool as our guidance. So our base recipe looks like this. Again, we used Hercules pellets to bitter and a mix of Mandarina Bavaria and US Cascade for the aroma part. Both of these were added to the whirlpool in significant amounts. So the final beer that comes out of this is really quite hoppy. Again, we did the same, replacing the bitterness part from pellets to CO2 extract. And the third version we did using Ike for the bitterness and hop oil type essential for the aroma part. It should come as no surprise that number 1 and number 2 are again very close in cost, basically the same, because the cost driver in this case is certainly the aroma dosage of the pellets. But when you compare this now to the third scenario with hop oil, you see a significant change. And that significant change is again only intake of ingredients. Savings on storage and shipping not accounted for, waste of wort and beer not accounted for. So this is giving you already a much better cost perspective. Is this beer the same taste as the ones done with the pellets? Certainly not. Is it one which is well-rounded and able to give you a nice hoppy boost? Certainly yes. In the end, it comes really down to how much do you want to go into this direction? What are the pros and cons of using the different types of products? And to summarize that basically, what I showed you is there are many special extracts for special needs. And they can be both used in the hot zone and the cold zone. Not the same product, but some products in the hot zone, some products in the cold zone. It is easier to split the aroma from the bitterness part when it comes to the cost impact for you if we do it in our factory, because you are either wasting one or the other if you're using conventional products. When you go for isomerized products, the Ike is by far the most efficient when it comes to the brew house. The iso extract would be the most efficient in the cold block, but there's a certain limit to how far you can go with this one. So a mixture is usually what's giving you the best performance. If you add hop oils, you have no loss because there's nothing to soak up your valuable wheat or wort or beer. And those losses, including the reduced volume for shipping and cold storage, should always be accounted when you do a full calculation of the cost of your beers. Will this mean that only extracts are the good thing and pellets are doomed to die? No, they're not. Pellets will continue to thrive. And basically, it's two reasons. First of all, you have the full variety spectrum available in pellet form. You won't find all of these varieties that you might like and look for and use for many years in the form of extracts. The second benefit is, of course, pellets have a great brewing value. They give you a very rounded, nice bitterness profile. They give you the aroma and the flavor boost. And that's why both are going to be there for the future, for sure. It's a question for you to decide what kind of beers would be suitable to use with extracts. What are your beers that you want to keep with pellets? Or what might be options for mixing both? And with that, I like to close my presentation part.
Yeah, Stephan, thank you very much. Very interesting presentation today. We also already have some questions. And as you just mentioned about the pellets and all the varieties that are available for this product, but not necessarily for the others. One question I would like to pick up with regard to the variations of the annual fluctuations of this product. I mean, everybody knows about pellets. It's the fingerprint of the cone, and it's the fingerprint of what happens in nature on this year in this region. How about the other products?
Yeah, that's one of the reasons why many people want to stick to extracts as well, because you have these big fluctuations, and especially the crop year 22 was teaching a lot of people what it can mean, because it was so bad in Europe. We had so low yields of alpha acids and also hop oil content in the hops. So you have fluctuations which are really there. In the extracts, we're standardized for the content of alpha acid, for example. So when you're getting a ethanol-based extract or CO2-based extract, we standardize on the value of the volume of alpha acid, and therefore even the dosage is much easier because you don't have to adjust your recipe every time you get a new batch coming.
Sure. Yeah, and I guess the same appears for the aroma products.
Absolutely the same. If you have the hop oil, you have the composition of hop oil, we standardize the lead components, and therefore, if you're using it this year, you can use the same dosage in 2 or 3 years.
Yeah.
That's not fluctuating.
Sounds very easy. Okay, another question that came up was about the storage conditions of hop oils and salvo. So I just double checked, and for the salvo, I'd like to say it's similar to conventional other extracts. So we come up to, so we have a best before date of 6 years or shelf life at the storage temperature below 10 degrees. And for the hop oils, we have 1 to 2 years. It depends on the type of hop oil. So the type dry family is on the 1 year side. All others have 2 years of shelf life. And we recommend to store them at 1 to 10 degrees.
I mean, since you're using so low volumes of these, storage is not a big deal anyway.
That's true.
You can quickly come with resupply if you need.
1 fridge more or less doesn't count that much. That's true. And another question was also about the foam, and is it affected by the hop oils? And well, if I may pick up this first, so if you consider hopping with pellets, either for dry hopping or in the late dosage in the brew house, you introduce a certain amount of aroma substances, and you do the same on the downstream side. So it's either the one or the other side where you introduce the same amount, and this means in the end that there's no real impact on the foam at all. So the later you dose, the more it might happen, but in general, we hardly see any influence on that.
Especially since we're not recommending to use the dry oil, which has all the components which are killing the foam. We removed a lot of those, leave in the water soluble parts, so even reducing the issue.
Yeah. Another one. Okay, now we have quite a couple of questions. So what about the polyphenol content and the contribution to beer flavor? So comparing extracts and pellets, of course, this is one of the main group hop substances that is not existing in the one or the other product. So you might want to say something about it.
Well, you do have a certain part of what you get with the ethanol-based extract, because you're extracting some of the polyphenols with this as well. Not as much, of course, as if you have it with the pellets. CO2 doesn't have it at all. It's a very delicate question, because polyphenols have their pros and cons as well. They add to the roundness maybe and the sensory perception. They will not help you so much with the stability. So it's always, yeah.
I agree completely. So it's a very good question, and I would say it's also something to be checked on your beer and your recipe. So depending on the malting recipe and everything, it can be either the one or the other direction. And if you do the dry hopping with pellets, of course, then you have the much higher impact of polyphenols on troop formation and so on. So a couple of things to be considered, but feel free to send us an email and we pick up this question more detailed, because we cannot cover it in a 5-minute Q&A session. Another question came up about Ike and if it can be isomerized further in the kettle, or is this the main benefit is the iso-alpha content in the product, I guess.
Yeah, further isomerization is hardly possible, right? I mean, it's pre-isomerized to the maximum. It's almost no alpha acid in its pure form there anymore. So there's not much that can further isomerize on this part.
That's true. So we have a very high isomerization yield or rate. So when converting CO2 to AIC, it's at least 95% is converted, even more usually. So there's hardly any residual alpha that would additionally contribute. Okay, yeah, then we have the question about labeling. That is, yeah, can we declare the hop oils as hops or hop extracts, or does it fall into the flavoring natural, yeah, legislation, additives, whatever?
I love this question. Yes, it's a very sensitive matter actually, because hop oils by definition are hop extract. They are extracted from hops in the most natural way of processing, which is steam distillation. Steam, hot water is the only solvent in this. So by all right, you can call hop oil an extract. However, there are some regulations and some philosophies about the regulations which make this difficult. Countries like Korea and Japan, for example, are not allowing this purpose because they say the purpose of using a hop oil is flavoring. So even though it's the most natural way a flavor can be, directly 100% from the hop, you have to name it as flavor. Other countries are more flexible with this. We usually recommend, if you're not in Japan or Korea, that you make a disclaimer to it. So if you're using only hop oil and you want to declare it as a hop extract, you should have at least a disclaimer with an asterisk for flavoring purposes or something like this, to make sure that the authorities don't think you're cheating consumers, because when a hop extract can be considered as everything in the bitterness and everything, how come you're using a hop oil in a flavored water and it does not look like hop, it does not taste bitter? That must be cheating. That cannot be a real hop extract. So it's a fraction of the hop, only the aromatic part. So if you're using it like that, we should recommend to make a disclaimer with it. If you're using it as part of an extract in your ingredients anyway, I think that's hardly any issue if you don't massively overdo it with the dosage.
I mean, you mentioned the most important thing in the first word. So it's really depending where you're doing the beer, and we have seen any kind of declaration already. So from hops to hop flavor, yeah. It can be the one or the other. Just ask us and for your specific question. And then we have two last questions. So the one is about pesticides. Is there carryover to those products? And I would like to say that there's no carryover at all. So purified hop oils are completely free from any kind of pesticides. And finally, we have a question about using hop oils for animal nutrition area.
Wow, okay.
Something completely different. And also if there's any possibility to think about using beta acids in this with regard to that. I guess it's a very complex question again.
Do you have an idea? To me, the beta acids part is very interesting for animal nutrition, for sure. The hop oils, for sure you could use it, but I'm sure there are more cost-effective ways to achieve the same. Because hop oil is extracted from hop. Hop is a very expensive starting material as a natural crop. So I would recommend the aromatic part looking somewhere else. The beta acids are certainly interesting.
Yeah, and there are a couple of studies where hops are being used for cattle feed, and there can be a lot of benefits. Yeah, so true. Okay, so thank you very much for joining our webinar today and the interesting questions we had. Time to close the session. You will receive an email to rewatch this video from today, and feel free to send us comments or anything that you would like to know more about the topics that we present. The next webinar will be held on the 6th of June. It will be done by our technical director, Frank Pfeiffer, and he will introduce a new liquid hop aroma product that has very high efficiencies and very interesting late hop characteristics. So reach out for the next invitation, and we are looking forward to see you soon. Bye-bye.
Thanks for joining.